We're looking at organic compounds going through oxidation and reduction, and hopefully by now you're getting the hang of these a little bit more, and you've been practicing, so you're getting better and better. All right, so what we're going to do on this last slide is just look at the same reaction in 4 different ways. Again, to hopefully help you connect and realize that when you see this, oh, I already know that. I'm seeing it written in a different way. So this is a reaction that we saw before. If I look here at my carbon-containing compound, this is ethanol. Through the course of the reaction, it loses hydrogens. So because it loses hydrogens, I could say that this is oxidized, and it's the reducing agent. And then NAD gains hydrogens. So I could say this is reduced, and this is the oxidizing agent. All right, and I'm going to use some colors, just random colors, to help us see the connections even a little bit better. So I'm going to draw purple for this ethanol, and I'm going to use pink for the NAD. All right, and then I'm also going to use yellow, which we'll see some more in the next segment of chapter 5 as well. Yellow was our color for a catalyst, and a catalyst is that helper, kind of like a teacher is a helper to enable you to do the hard work of learning chemistry. So this is just a helper. It's not a reactant, not a product. It's just there to help make this reaction go faster. So a couple of ways that you might see this same reaction written. You might see it drawn maybe in like a bio type textbook or physio with more of a sketch here that shows some of the shape. And so what I would have here is I would have the alcohol dehydrogenase, which is the enzyme, is this dark gray thing. And the enzyme helps by holding everything together, right? Kind of like my videos make you sit there with your lecture notes and your brain all engaged. So that's what the helper does, is holds everything together in the right place. And then the NAD is sitting here. And then next to it is the ethanol. And that's one of the ways that enzymes or catalysts, they're the same thing, help a reaction happen faster, is they just hold all the things close to each other, and that means that these are more likely to react. So in this sketch, here's my NAD reacting with my ethanol, and here's the helper for all of it to happen. Here's another way to see this, and this is sometimes called a curved arrow diagram. And this helps us focus on what we call the substrate, like the actual thing you ingested that you're working on. The rest of this is all kind of helpers, so I want to think about what happened to that thing that I ate or that thing that I drank. So the ethanol, this is just a different way of drawing out these same atoms, 2 carbons, 6 hydrogens, 1 oxygen. The ethanol comes over to that helpful enzyme, and at that enzyme, the enzyme says, hey, I'll bring this other NAD in. And so notice with the curved arrows here, this is the reactant, comes in, and this is the product. And that's the same as the reactant and the product. Sometimes these H pluses and charges are a bit different in different versions of the same reaction. For this class, just ignore the charges. We don't care if they're there or not. For our intents and purposes, this positive we can ignore or have it there, whatever. But what I care about is that ethanol comes to the helper, the NAD comes in, and the NADH comes out. All right. So one more way we want to be able to see this same reaction, and that is as a half reaction. A half reaction says, you know what, let's just focus on, say, the ethanol piece of it. I don't care what happens to the ethanol, I just want to, or what else is happening, I just want to know what's happening to ethanol. And that's where half reactions come in useful. We'll use these throughout the rest of the semester. So the oxidation half reaction is going to just show what happens with that pair of chemicals that are involved in oxidation. So I might write this like this: C2H6O turns into C2H4O. So I'm grabbing just that half. And then I need a helper, right? In order to become oxidized, something's got to suck those hydrogens up. And so what we do is we just write a generic bracket O over the arrow. And that bracket O is saying, hey, we have an oxidizing agent. Something came and took those hydrogens. These half reactions are rarely balanced, so this is kind of our cheat to say, hey, the hydrogens disappeared, okay? Now, as a little side note, we actually do know the whole story here. So we actually know in this reaction that, what's my oxidizing agent? The NAD is, right? NAD is the oxidizing agent that took the hydrogens. So here we know the whole story, okay? But sometimes we don't care about telling the whole story or seeing it all. We just want to know ethanol became this product. So we focus on that half of what's happening, and we don't even say what specifically is that oxidizing agent, even though we might know what it is. All right, if we can do an oxidation half reaction, we can do a reduction half reaction. So I can take my NAD and say NAD turned into NADH. It was reduced, and like we had over here, we had that helper that helped with it. So we have the reducing agent, and so my NAD turns into NADH. And again, behind the scenes, we actually know what that reducing agent was. It was this ethanol, but we're not focused on that right now. We maybe just want to know what happened to the NAD. So you've got this type of reaction. We can show the same reaction as a shape drawing. We can show it with curved arrows, or we can show it with half reactions. And I've given you a sheet to practice that for another reaction here. So you can work ahead on that a little if you want. Bring questions. We'll go over this together in class.